first.
I think it's 94 cents or something. So now it's like almost $3.
I know, and I need some lumber too. I can't never remember what I'm doing. Y'all see my screen? All right, you want to do series first or parallel? Okay. I guess we're doing parallel. Let's call this 62 volts. Let's call it 38 kilohertz. We'll do 4.15 kilo ohms. And we'll do 4 nanofarads. Yeah. Okay. I don't care how you guys do this. This is just how I do it. What's the total resistance in this circuit called? What is it called? Impedance. Voltage of the resistor. Current through the resistor. Resistance. Voltage across the capacitor. Current through the capacitor. And what is the resistance of the capacitor in this circuit? Mm-hmm. That's the capacitance value. What is its resistive value? What do we call that? Starts with a C and rhymes with capacitive reactance. Why we're doing this, I figured you guys could use a little bit more practice. Okay, what can we do right off the get-go? Yes, but even before that, we can put some of these values in right away, right?
So voltage. Is the E, what's the E instead of, can we use the E for B?
That's how I was raised, bro. Look at your ugly book.
Oh, I know. So you get used to the B because.
Real electricians say E. You wanna be a real electrician? You wanna have plywood windows or do you wanna have 15%ers? Anything else we can put on here? Yep. 4,150 ohms. Anything else? Is it a parallel circuit? Look at all that stuff we can do right off the get-go.
Yeah, we can find the.
Yep, we can find capacitive reactance, we sure can. 4.2. That look right?
Yeah.
They got a calculator in front of them?
Yeah. 1.99, 1.23.
I have no idea what you just said. What? 1.4
1.992.
kilo ohms?
Mhm.
So if I said 1,009, what?
9,
994,
4, 4,
4. Give me another one.
22.
Okay. Ohms. Remember, when I do this, I don't care how you do it, but when I do it, I make all the units the same. I get rid of all the kilos, megas, minis, micros, nanos, giga, giga stuff. What else can we do?
Current.
Find the current through the capacitor
Mhm.
using what law? Ohm's law. By the way, on your formula sheet, this formula on there for on the parallel RC circuits.
Different number.
Yeah.
Lewis,
Half that,
Lewis,
997.21
Lewis.
Okay, don't believe me, okay?
You're telling me this is wrong?
Yep.
Lewis,
Yes, I know. I do it all the time, bro.
The crappy part of that is if you do get it wrong on the quiz, you're gonna use that value now for Ohm's law,
Yeah,
right?
yeah.
So double, triple check yourself if you need to. One divided by left parentheses, 2 times 5 times 1,000 times 20, 0, 0, 0, 0, 0, 0, or 2, right parentheses, equals 997.21. You know what you did wrong? You know what you did wrong, or
Yeah,
Chris,
I know
you
what
good?
it is, man.
Okay, good.
I put 4.2 nanofarad.
Take a little gander at our thing there. What are we on? RC parallel. If we go to current, there it is right there. IC equals VS, which is source, but in a parallel circuit, the voltage across the capacitor is the same as the source, right? But just Ohm's law, I equals E over R. I equals V divided by X and C. Okay,
So this 42 nanofarad, so it's 4.2.
4.2 times 10 to the minus ninth.
Yeah,
What's your question?
that's around because you write down 42.
Here?
Yeah.
Because I wrote it all out, 0.0000000042.
So if I do it on my calculator and then do 4.2
Then
nanofarad.
E minus 9. You should get the same answer. You get it?
Okay.
Did you hit right parentheses when you were done?
I forget the left one.
What?
I forget the left one.
You forgot the left one?
Yeah.
That's a problem.
Yeah.
Do we need to wait for you? to Figure your calculator out, or should we move on? Okay, so Ohm's law says the voltage across the capacitor, which we know is 62, divided by 997 to 1. What does that give us? I'm getting 62.2 milliamps. 0.062173 amps. What else can we do? It's all for the current through the resistor. Using what formula? Sure enough. $62 divided by 4,150. What does that give us? Zero, 0.014 994 amps. What else can we do?
Total.
Total's impedance. Impedance. What's the formula for that? Is it on your formula sheet? Sure enough. What's the formula?
R resistance 1 squared. Plus.
Like that? If I take 4150 squared plus 997.21 squared equals, I'm going to take the square root of that. I get 4,268.13. Can we solve for total current now? Sure enough, using what law? Sure enough. Is that on your formula sheet? Sure enough. And I get 14.53 millionths. Yay! Like it? Love it? Want some more of it? Hey, what? What the? No, I don't. Actually, I don't. You're gonna have to use the one on your computer. You know how to do that?
I'll make sure.
Yeah, I mean, when you search for calculator and you pull it up, it's gonna look like gonna look like that, but if you go view, scientific, then you get the parentheses and tangent and square root and all that good stuff. Okay, everybody good on this? Should we do a series one? Don't want to do a series one? Yes? Yes? Kevin? Huh? You want to do a series one? Yeah.
Question.
What's up?
In my brain. On the sheet here, the parallel,
Uh-huh.
the formula for impedance, it has the square root of XC squared plus R squared, but we want to divide it by, or that's XC times R divided by that on the formula sheet.
Oh, yeah. I make a mistake.
That was series, wasn't it?
Yeah, that's for series. For parallel, we have to use this one, don't we? Oops.
Parallel, I was just gonna figure the two resistances times themselves divided by the addition of the two.
It's got product sum. Why is that? Because they're in parallel. Yeah, I mean, we have this formula here, but we couldn't use that in solving our thing because we didn't have total current yet.
Right, so for the two resistances, I had XC was 997.21, and then we had 4,150. Took those two numbers, multiplied, and then divided those by the sum of those two numbers.
Yeah, I think I did that wrong, folks. We need to back up. Because we're in parallel, I think that's. Oh. Remember at this point, we were solving this. We didn't have current, so we can't use this formula yet. We could if we added up these two values. That would give us total current. And then we could use Ohm's law to find impedance. But I hope I didn't just royally screw up your brains by doing that. Either way, let's make it right. Let's solve it both ways though. Okay, so back up to where we were before. We hadn't solved for impedance or total current yet. So using this formula down here, total impedance equals X sub C, which is 997.21 plus, no, time R, which is 4150. Divided by the square root of X sub C squared plus R squared. And this bottom number is what we found before, so we just didn't take it far enough. Oh crap. I'm glad you caught that though. Okay. Anybody remember what that number was before? It's okay if you don't. I'll just put the whole thing in the calculator. 997.21 times 4150 equals divided by parentheses 997.21 squared plus 4150 squared square root 4268.13. It looks right to me because it's the top product divided by the square root of these two squared added to each other. So 4268.13. What was our last number?
So that was your total impedance from 4268 to parallel. I mean, looking at it, it had to be smaller than your largest value, and
Right,
it wasn't.
right. That's a good point. You see what he's saying?
Yeah.
He caught me on my blunder and it all makes sense. So total impedance, since it's parallel, is going to be less than the two individual values, right? Because when you parallel resistances, total resistance goes down. 4268.13.
Yeah, well, that's, and then that has to be, you have to have the sum of those two, XC and resistance, or I'm sorry, product of those two divided by that 4268.13.
Right.
I came up with 969.610.
So you got a number that was less than that?
Yeah, because it's divided by 997.21 divided by 4.1160.
So I took X sub C times R,
Mhm.
997.21 times 4150. And I got a value of 4,138,421.5 divided by the square root of that squared plus that squared.
Well, see, okay, I took the two squared, 997.21 squared plus 4150 squared, and then the square root of that. So,
Right, and then you need to take, that's this part down here. what you just described to me was this part down here.
Yeah, that's 4268.13.
I just did equal sign after what you did, and then I got the number.
Oh, I haven't hit it. Oh, there it is. Okay. So that was the same number we came up with last time. This is 4268.13. Right. So, okay, so I hadn't finished the deal. My bad. I think Joe should come up and teach the class now, please.
I have to move.
You have to poop?
Oh, well, I thought if I have to speak, I do.
Oh, come on.
All right.
I do a word.
Yeah, I gotta go poop. 969.61. All right, now it's all driving. All right, when we use that to find current, this current value that we come up with should be equal to these two values adding together.
Right, you can add those.
So what I'm saying is there's two ways to do this. What we just did, and then using Ohm's law, or you can add those two currents up and then use Ohm's law to find total impedance. So what we had done before, when we came up with an answer of 4268, whatever, for total impedance, that would have been wrong. That would have given us a current value that's not right. But let's go ahead and solve using Ohm's law. I total equals E total over Z total. 62 divided by 969.61. I'm getting 64 million. Is that right?
Yeah.
Four. So why isn't the current additive then? 0.62 plus 0.1, 0.014 plus 0.0, that's 0.076. Why is that?
Because it was a square. It was 63.94 square. It's not there. It's the own law, but and then I think you have to square it up. And they give you
Explain that to me again.
it's a recurrent, it's a X. It's a recurrent, it's like,
Oh, this is what you're saying?
yeah.
Okay, because it's not additive,
Yes, added it, but in the end, you have to square it up,
right?
and then you get total current.
If we double check ourselves with this formula,
What number you have? 63.94.
right? We used Ohm's law to find this number,
Yeah, now you square it.
which should be right, but we can also take the square root of 0.01494 squared, which is this value. So ignore this, you can't just add them. Add them and then take the square root of it. Add them. It's this formula. Plus 0.062173 squared. So whatever we do here should match 0.06394. Oh yeah. Oh yeah. Now we know we did it right. Okay, does everybody understand my error and how we remedied it? So if you'd have done this on the quiz the way I showed you the first time, you'd get 2 answers wrong. Doesn't that suck? Oh, man. We'll get through it. All right. Series. Call this 73.6 volts. And we'll call it 1.21 gigahertz. Just kidding. 38 kilohertz. Series R will make it 4.15. I don't care. Kilohertz, kilo ohm. Capacitor will make it 4.15 nanofarads. E total, I total, V total, ER, IR, bar, EC, IC, X sub C. We can put 73.6 volts up here. We can put 4.15 kilo ohms right here. Anything else? Beyond that, we're kind of screwed, aren't we? What can we solve for first?
Well, we need that. About the reaction.
What's the formula?
So 1525.
Correct. This is going to be 1 divided by 2 times pi times 38,000 times 0.000000. Zero, zero, 415.
No, oh,
Anybody else hear that little conversation? That was hysterical. What'd you get for that one, Joe? I have Red Bull.
Yeah, you got wings, not two.
Joe's got wings. 2 times pi times 38,000 times point 0.00000000415 right parentheses equals. I got 1,009 ohms. Cool, now what? Impedance. What's that formula?
R squared.
Are we sure? Because this is where I screwed it up last time. You're right, but you can always look on here. So this is X sub C and R in series. Resistance, total impedance right here. If I take this and just go squared plus 4150 squared equals square root. That doesn't look right. $41.50 squared plus 1009.23 squared equals square root. There we go. 4270.95. Now what can we solve for? Just use Ohm's law. 17 milliamps. Two, three, three. Now what can we do?
This would be your total for your current and the other.
Series circuit, I mean, this is the same. And this is the same. So now can we find the voltage?
Mhm.
Let's double check on here. Voltage. Total voltage equals blah, blah, blah. Well, we're given the total voltage here. Voltage on the resistor equals E equals I times R. Voltage of the capacitor, E equals I times X sub C. Cool.
Ohm's law, right?
Yep, just Ohm's law. Total voltage, if we were given those and we had to find total voltage, you'd have to use this formula
The same one.
because of the trig,
It's the
right?
same formula with the parallel, right? Remember what parallel with that?
Same as in parallel?
Yeah, for, for Twitter.
Well, in parallel, the voltage is all the same, right?
Yeah, no, for current,
For current,
yeah. That's it.
yeah, current uses this formula in parallel. Voltage uses that formula in series,
You see it, yeah.
right? But in this case, we're given total voltage. We don't need to worry about this. What we need to worry about is this
Okay,
and this. If we were given both of those and we were trying to find voltage, that's how this formula is derived. It's trig. But we don't care. We just want to keep it simple in our little brains. At least I do. Okay, so if that's the case, that divided by 4150. I'm getting, what?
You multiply those, huh?
Yeah. E equals I times R. Dumbass. Hey, I've been known to make mistakes every once in a while, folks. Sorry about it.
Especially on Thursday.
Yep. Especially right before you guys are gonna take a quiz. But I'm not taking this quiz today. I'd fail. I'd fail it. You guys are all sitting here going, fuck you, Zach. Oh, man. Times what? 0.17233. $715.2. One seven. And C equals I sub C. X sub C. 0.13 times 1009. One 73.92. What? What is going on here? Isn't that right?
What? For the voltage?
I'm getting a voltage across the capacitor of 173.92.
That should be 17.3. Oh, you just put a 0 in front of your milliamps over there in your formula. You got point.
Oh, yeah.
Uh,
No.
uh,
Second time you think it.
I should just stop right now, folks. Just let you take it. 0.17233 times 4150. 71.52 volts. There we go. This would be point. Is there a way we can double check ourselves on those? Did you guys get the same answers as me? 1771. Is there a way we can double check ourselves? Maybe using this formula? If we do this with the numbers that we got, we should get 73.6 volts, right? So this would be the square root of 71.52 squared plus 17.39 squared. Boom. 73.6 volts. All right, everybody happy? You want to take a break? You want to jump into the quiz? Jump in? Okay. Here's what I'm thinking. Probably everybody in here has quizzes to finish up or labs to finish up. We'll make Tuesday lab day. And then depending on when everybody gets done and caught up, then we'll do, we'll look at the next chapter. I want to finish up capacitive reactance in our labs before we move into inductance. So I don't remember when's your next homework assignment due? Tuesday? You want to leave it at that? Chapter 18, or you want to push it back? The more we push stuff back, the more condensed things get towards the end. We've only got about a month left, so. All right, we'll leave the chapter due on Tuesday, but let's start out with the labs. Well, we'll see. Maybe we'll go over the homework and then do the lab. Why don't we just say, take a vote when we get in here? We can talk about window tent, we can go over homework. You guys want to take a quiz, don't you? I'll shut up. Okay, well, when you're done with your quiz, I think we'll call it a day with that one. Instead of waiting for everybody to get done and then doing 5 minutes worth of a lab, we'll just call it a day. Chapter 17 quiz should be available to you. You cannot use these. Just go, dude. Just go. Do it. Right, you can't use these. So make sure you don't have those, but you can use scratch. Anybody use scratch paper?
What if I scratch paper with orchard?
You can't use those, bro. Somebody use scratch paper? You can't use your formula sheet. Yeah. Anybody use paper? No? No, they do. Okay. Everybody's got a formula sheet?
I don't,
You don't have a formula sheet?